The next demonstration is the moment of inertia wands or moment of inertia rods. By itself, these may not seem that hip, but we use these a lot in combination with the figure skater demonstration, where you bring your arms in, or the clay on a stick demonstration, which we'll show you at another time. So first I wanted to show you we have two versions of this. The new ones here are these plastic jobs, and the old ones are these two metalworks. And the first thing you want to do when somebody comes up is say, here, I want you to check something. I want you to pick up these two rods, and you want to hold it right in the middle, because that's where you want them to hold it. I want you to pick up these two rods and verify that they are the same mass. So you have them pick that up, and you want them to grab it right in the center, because they're both balanced right at the center. And that's why these have an advantage. There's an obvious handle. So pick up these two rods and make sure they're the same mass. Then you say, okay, now what I want you to do is pick them up, hold them in the center. It's key, you got to have them hold it in the center, and try and rotate it back and forth. And you'll notice that one of them rotates much easier. And to show you here, same thing here. I forget which is which. Oh, it looks like the red is the easier one. Okay? So then you say, how come, or why does the red one rotate easier than the blue one? They're the same mass, and so that's the puzzle that you stick them with. Okay, you say, why do these two with the same mass rotate? And the key is you want to get them thinking about mass distribution, or moment of inertia. So in this case, if you look at these rods, you'll notice in the ends that one of them has all the weights at the end of the rod, and the other has all the weights in the center of the rod, just like these guys. So one of them has the weights all in the center at the pivot point or axis of rotation, and the other has all the weight out here at the ends. So an object like a figure skater with her arms out is much harder to rotate. They typically rotate at slower rates. We say they have a large moment of inertia. Now, a sloppier way of saying this would be you could say you have a large rotational mass. Rotational mass depends not only on your mass, but also how far that mass is from its pivot point or axis. So in this case, my arm is like the axis, or my hand is this pivot point, and we see that in this case, the mass is far from the pivot point. In this problem, the mass is essentially exactly on the pivot point, so there's almost no moment of inertia or rotational mass. Again, rotational mass, moment of inertia, pretty much the same thing, although moment of inertia is the proper term. So that's the basic demonstration. You can go a little bit further if you want, and you can challenge people. So what you can do then is you can hold the rods at the end. And this is not the standard way of doing this, but then you try and rotate it, and you can see you can do it roughly at the same rate. It's pretty easy for both of them. And you might be saying, well, why? In this case, you have two masses inside of here that are this far from the pivot. In the blue case, the mass is at the ends. So one of the masses is actually on the pivot, and the other mass is a distance 2L, or twice the center distance, or full length of the rod, if you will. So in this case, there's one mass with a distance of the full length of the rod. In this case, you have two masses with half of the distance. Strictly speaking, they don't have the same moment of inertia, but they're a lot closer, and so you can almost do these at the same rate. And so that's kind of a bonus there you could use. That's the moment of inertia wands.